on a new scale of temperature which is linear and called the W scale. W scale, the freezing and boiling point. The freezing and boiling points of water are 39 degree W and 239 degree W respectively. Okay. What will be the temperature on the new scale? On the new scale, corresponding to a temperature of 39 degrees Celsius on Celsius scale. Okay, see the question. We got it on a new scale data. This is your on a new scale. On a new scale of temperature which is linear and it is called as of a W scale. The freezing point and boiling points of water are 39 degrees W and 239 degrees W respectively. What will be the temperature on the new scale corresponding to the temperature of 39 degrees Celsius and Celsius scale? Anyone? Direct form yesterday which I told you. Temperature on your W scale. Temperature on your W scale minus lower fixed point is 39 degrees Celsius divided by upper fixed point is 239 minus of 39 is equals to, on Celsius scale it is 39. See, on Celsius scale it is 39 minus, on Celsius scale the freezing point is 0 divided by, this is your 100 minus of your 0. Okay, so if I simplify this one, temperature on W scale minus 39 divided by, this is your 200 is equals to 39 divided by 100. Okay, so this one and this one will get cancelled here, this two. So it will be a 2 right now for me. So it will be equal to how much beta anyone? TW minus of 39 is equals to your 2 into your 39. So it will be 9 to the 18. So it is your 8167. This will be 78. That means temperature on W scale will be equal to 78 plus 39. That will be equal to 117 degree of W. Done? Done, beta? So, next heading beta, triple point of water. Triple point of water. Anyone is having idea of triple point of water beta? It is a point where pressure and temperature, I can say the pressure and temperature can exist in all the states simultaneously. Okay, so let the definition, the pressure and temperature The pressure and temperature at which the substance can exist in all the states simultaneously. All the states मतलब क्या बेटा? Solid, liquid and gases is called triple point. Is called what? Triple point. Okay. Of your substance. Okay. So I'm talking about the triple point of your substance. So I'll write here this one as substance. Sorry. Triple point of your substance. Then we'll directly talk about your water. So the pressure and temperature. The pressure and temperature at which a substance can exist in all the states simultaneously is called as what? Triple point of that substance. Okay. All the states means solid, liquid, and as well as of your gases. And what is that pressure, beta? That pressure is 4.59 mm of mercury millimeter. That is equals to 0.459 centimeter of mercury. That value is 610.2 Pascal. So this is the pressure at which solid, liquid, and gases can exist. Okay. And what is the triple point of the substance, beta? Triple point of the substance is 273.16 Kelvin, which we call it as of 0.01 degrees Celsius. So for calculation purpose, we take approximately your 0. Am I clear? So the pressure and temperature. What is the pressure at which the substance will exist in all the states? 4.59 mm of mercury or 0.59 centimeter of your mercury or 16.2 times of your Pascal. So triple point will be 273.16 Kelvin or also called as 0.01 degree Celsius point of relation. Okay, see here. If I'm talking about volume thermometer and pressure thermometer and your pressure thermometer are constructed on basis of this triple point. On the basis of this triple point of water. Okay. Now see, if I'm talking about volume thermometer, volume thermometer, it says that volume is directly proportional to your temperature. Which law is this one, better? Charles law, isn't it? So volume of your triple point is also directly proportional to the temperature of your triple point. This is my equation number 2. And this is my equation number 1. So if I divide both of them, so it is V divided by volume of your triple point is equals to T divided by temperature of your triple point. Okay, so I can calculate the temperature from this one. So T is equals to your V divided by volume of triple point multiplied by temperature of your triple point. So the temperature of your volume gas thermometer can be given by the formula T is equals to V divided by V triple point into temperature of your triple point. That means I can write this value as capital T is equals to triple point temperature is how much better? 273 point of your 16 multiplied by your V divided by volume of your triple point. If that data has been given, I can calculate the temperature by using this formula. Okay. So volume gas thermometer is based on which law, beta? It is based upon your Charles law, where it says that volume is directly proportional to temperature. Now, volume of triple point is directly proportional to temperature of a triple point. If I take the ratio and simplify it, we are getting T is equals to your V divided by volume of triple point into temperature of triple point. That means if I simplify this relation right now for me, T is equals to your 273.16 because that is the temperature of a triple point into your V divided by volume of a triple point. Clear? The same way I can even define pressure thermometer better. Pressure thermometer. Okay. Pressure thermometer. Pressure thermometer works again on the same principle beta. It says that here pressure is directly proportional to temperature. Pressure is directly proportional to temperature and pressure at your triple point is directly proportional to temperature of your triple point. This is my equation number 2 and this is my equation number 1. If I take the ratio of both of them beta, T divided by your temperature of your triple point is equals to your P divided by pressure of your triple point. That means if I take the value of T is equals to your P divided by pressure of your triple point multiplied by temperature of your triple point. So first we'll simplify for this one and write it because I know the temperature of your triple point. T value will be equal to T is equals to your 273.16 into temperature of your pressure divided by triple point pressure. So this will be the formulas to calculate the temperature of your pressure thermometer. Okay, so for pressure thermometer, we are using the formula of your T is equals to 273.16 multiplied by your pressure of that given gas divided by your triple point temperature. Okay. Done better? Sure. Next heading. Next topic in this one beta, calorimeter. Very important and small topic beta. समझना बहुत ज़्यादा important है. Calorimeter. So how do you define the calorimeter beta? First point देखो यहाँ पर. Amount of heat required. Amount of your heat required to raise the temperature of the temperature of 1 gram of substance. 1 gram of substance by 1 degree Celsius. 1 degree Celsius. It is denoted by S. Okay. So what is the calorie beta? Amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. And it is denoted by S. Am I clear? See a formula. S is inversely proportional to the mass and directly proportional to the heat produced. That is dQ divided by your dt. Okay. So from this one I can even write S is equals to 1 by m into your Q divided by rise in temperature. That is your delta T. Okay. So if I take the Q on either side, integral of your dQ from this equation, that is equals to integral of your m into S into your dt. Okay. Integral of dQ is right now how much for me? Q. That is equals to integral of your m into S into your dt. Temperatures of this one is lower temperature T1 and upper limit is right now for me T2. So the Q can be given by the formula if mass is variable with respect to your temperature, then Q is equals to integral of your M into S into your delta T. Okay. Units of this one is, can anyone tell me the units better? SI unit of this one is joule per kg Kelvin. Isn't it? Energy is measured in joule, mass is measured in kg, and temperature is measured in your Kelvin. Okay, and its CGS unit is calorie per gram Kelvin. Because degree Celsius or Kelvin, it will be one in the same part of relation. Am I clear? And these are some of the important points which you need to remember better. I already told you. 1 calorie is equals to 1 calorie is equals to 1 calorie is your SI CGS unit beta. 1 calorie is equals to 4200 joule per kg Kelvin. Okay. And the specific heat of water is generally taken as 1 calorie per gram degree Celsius. Okay, that is also taken as 4200 joule per kg Kelvin or degree Celsius. One and the same. Okay, the same way, specific heat of your ice. याद है किसी को? Anyone did remember what is specific heat of ice? It is 0.5 calorie per gram degree Celsius, or it is 2100 joule per kg Kelvin or degree Celsius beta. K is also equal to C here because number of divisions of K is equals to your number of divisions of your C. That is the reason whether I write it K or C should be taken as one and the same for the small changes, because 1 degree Celsius change is very, very small. So come back again. So how do you define this? What do you call that in specific heat? The amount of your heat required to raise the temperature of 1 gram of substance by 1 degree Celsius is equals to your 1 calorie. So calorie is right now for me the basic unit for your S. So whatever heat I'm giving right now for any substance, if I write mathematically, delta Q is directly proportional to your mass. Delta Q is directly proportional to the temperature difference. That is nothing but dt. And if I remove these relations from both of them, delta Q is proportional to your m and as well as of your temperature rise. So delta Q, if I'm removing, we're getting some constant known as S into M into your dt. So that is the way we got this relation from your S is equals to your 1 by M into dq by dt when energy is as a function of your temperature. Or else I can, if I take the energy is equals to constant, directly you can use the formula S is equals to 1 by M into Q divided by delta T. And basic standard formula for this one to do the numericals is Q is equals to your Ms into your delta T. Delta T is your temperature beta. T1 and T2 are right now for me temperature. SI unit is joule per kg Kelvin and CGS unit is calorie per gram Kelvin. 1 calorie is equals to 4200 joule kg Kelvin. These are points you need to by heart it and should be committed to your memory beta. The next one is specific heat of water in CGS system is 1 and in SI system it is 4200 joule kg Kelvin. And specific heat of ice, very, very important, 0.5 gram per degree Celsius or 2100 joule per your Celsius part definition. Am I clear with this one? Am I clear? Any doubt in this one? Am I audible, beta?
Yes, sir.
Sure. So I hope you are clear with the first formula of the calorimeter beta. What is the first formula of the calorimeter? Q is equals to ms into delta theta. Standard formula if I need to write here beta, I'm writing here you see. Q is equals to m into s into your delta theta. Delta theta is your temperature. dt is also your temperature beta. Okay. So you can even write this one. M is the mass, S is the specific heat, and delta T is your rise in temperature. Rise in your temperature. Q is right now for me heat. This is a form of your energy. M is equals to your mass and S is your specific heat. Okay. And M is your mass. Okay. Now see. See this point beta. Very important. Specific heat of a substance. Specific heat of a substance is independent of. It is independent of mass of the substance. Mass of the substance. That is nothing but delta T because it is a constant. Okay. On what the specific heat will depend beta? Specific heat depends on nature of substance. Depends on your nature of your substance or I can say the state of your substance, whether it's solid, liquid, or your gas particulation. Accordingly, it will be changing. Okay. Among liquids, among liquids, mercury has mercury has least specific heat, least specific heat, and hence it is used in clinical thermometers. As a doctor, you should know why mercury is being used in the thermometers, because among the liquids, mercury is only the substance which is having the least specific heat, and hence it is used in the clinical water. Why don't we use water, or we don't use another liquid? Means you should be giving an answer that among all the liquids, mercury has the least specific heat. That is the reason it is used in your clinical thermometer. Okay. Let's see. Specific heat of water. I'll write it. Specific heat of water is greatest. Can you tell me where it is being used? Hence, it is used in last year in 12th class, you might have been studied in nuclear physics, in nuclear reactors. They are used in the nuclear reactors as a moderators. Nuclear reactors as moderators. Very important point. Okay. So, which liquid is having the least one beta? Among all the liquids, mercury has the least specific heat of water, so it is used in the clinical thermometer. The next one is specific heat of your water is greatest, and hence it is used in the reactors as what beta? Moderators. In the nuclear reactors as of your moderators. Am I clear?
Yes, sir.
Thermal capacity. Thermal capacity, or other name for this one is heat capacity of your substance. Very important terminology. Thermal capacity or heat capacity of your substance. Okay. Thermal capacity is defined as beta. It is the amount of heat required. It is the amount of heat required to raise the temperature of a substance by 1 degree Celsius. Okay, that means dq divided by your dt is equals to m into s. This product of m into s is represented by letter h. This h is known as of your heat capacity. Okay, so what will be the SI unit beta? SI unit will be equal to joule per Kelvin, isn't it? Because Q divided by dt. And CGS unit will be of heat capacity, calorie per Kelvin or degree Celsius. And you know that 1 calorie per Kelvin or degree Celsius is equals to 4.2 joule per your Kelvin. Clear? So what is the specific heat formula beta? dq by dt is equals to m into s. M into your s part of relation is known as of your heat capacity. Am I clear? Heat capacity किस पे डिपेंड करते हैं बेटा? This is already theoretical question. Try to remember. Heat capacity depends on number one. It depends on mass. Number two, it depends on your temperature. That is your delta T. And also it depends on your nature of substance. Depends on nature of your substance. Specific heat depends only on nature of substance, whereas heat capacity depends on your mass of the body, temperature difference, and also the nature of your substance used. Am I clear? Sure. Now tell me the answer for this one, anyone better? If someone asks you, what is heat capacity per unit volume? What is heat capacity per your unit volume? Heat capacity per your unit volume. Heat capacity matlab m into s divided by volume. Mass by volume is density. So it is rho into s. Okay. That means for a given substance, if the density and the specific heats are constant for a given substance, if rho and s density and specific heats are constant then I can say that heat capacity is directly proportional to volume. Okay, V is your volume here. क्योंकि rho into S will be equal to constant. अगर ये constant हो गया तो heat capacity is directly proportional to the volume. Theoretical questions बनते हैं बेटा इसके ऊपर. So be a little bit careful related to the heat capacity and its definitions. Am I clear? Done? ज़्यादा लेट हो गया बेटा, sorry. चलो. What is the thermal capacity I told you? It is the amount of your heat required to raise the temperature of your substance by 1 degree Celsius. So dQ by dt is equals to m into s, where m into s is known as what? Heat capacity. So SI unit of the heat capacity is joule per Kelvin or calorie per Kelvin. And 1 calorie per Kelvin is equals to 4.2 joule per Kelvin. Heat capacity depends on what, beta? Heat capacity depends on number one, mass, temperature, and nature of your substance. Done? And heat capacity per unit volume is how much, beta? Heat capacity per unit volume, that is H by V is equals to ms divided by V. Or it is rho into S, which will be your constant. So for a given substance, if density and specific heats are constant, then heat capacity is directly proportional to your volume. Am I clear? Calorimeter is very important topic, beta. It will take small time. So we'll try to complete this one. They already showed 6 o'clock. Definitions are very important. So the first definition what we learned today is Q is equals to ms into delta T, where Q is heat, M is mass, S is specific heat, delta T is rise in temperature. Specific heat of water is 1 and specific heat of ice is 0.5. You need to remember this one while doing the problems of your calorimetry. When ice converts to water, water converts to vapor for that one conditions. Specific heat of a substance is independent of mass of your substance. Specific heat of your substance is independent of mass of the substance for theoretical question. Specific heat depends on what? Nature of your substance. I can say state of your substance like solid, liquid or gases. So among liquids, mercury has the least specific heat and hence it is used in the clinical thermometer. Specific heat of water is greatest, hence it is used in the nuclear reactors as of your moderators. If you get one theoretical question, this 4 mark will be in your pocket if he's asking anything data related to the specific heat. Next one and very important is, हाँ बेटा समरीन बोलो.
No sir, nothing.
क्या बेटा?
कुछ नहीं sir.
Okay, चलो. Next one is thermal capacity or heat capacity of a substance. What is the thermal capacity? It is amount of heat required to raise the temperature of that substance by how much? 1 degree Celsius. 1 degree Celsius बहुत छोटा रहता, इसीलिए delta K will be equal to your delta C will be taken. Delta K will be equal to delta C. So whenever I write as K is equals to C, it should be understand that the temperature difference is very, very small. Or even though if they are larger, the number of divisions are same, so K can also be represented by C. So what is the thermal capacity formula beta? H is equals to M into your S. Heat capacity H is equals to M into your S is known as of your heat capacity, product of mass and specific heat. SI unit is joule per Kelvin and CGS unit is calorie per Kelvin. And you know that 1 calorie per Kelvin is equals to 4.2 joule per Kelvin. Heat capacity depends on what? It depends on mass, depends on temperature, and also depends on nature of your substance. Heat capacity per unit volume is always constant. So we can say that heat capacity is directly proportional to your volume. So these are 2, 3 formulas which you should be committed to your memory. And next topic is water equivalent. Very important terminology. It is exactly equal to heat capacity better numerically. Water equivalent. I'll complete it in 5 minutes better, then you can go for namas. So water equivalent is the amount of water, the amount of water which has same thermal capacity. किसके पास? Water के पास. The amount of substance which has same thermal capacity as that of given substance is called water equivalent. Very important terminology. Okay. Like say for example, if there is certain amount of liquid in this one, okay, and there is some solid here right now. This is mass of solid, specific heat of your solid. This is mass of water, specific heat of water. Whatever amount of heat I give for this solid, if I give same amount of liquid, amount of energy to your water, whatever rise in the temperature is seen for the substance or solid, the same amount of rise is also seen for the water. That is the reason we say that mass of water into specific heat of water will be equal to M into S of your body. That is specific heat of your body. That means mass of water will be equal to your M into your S of your given body or substance divided by specific heat of water. Okay. So what is the water equivalent? This M is known as of your water equivalent. Okay. If I give 1 gram of heat to the solid, isn't it? And if I give the same amount of heat to the liquid also, we have seen that there is a rise in temperature by your 1 degree Celsius in both of them. Okay, so in both the cases, heat is right now for me same and temperature is also same. So temperature on both the sides will get cancelled. So we are getting mass of water into specific heat of water is equals to mass of body into specific heat of body. So mass of water will be equal to heat capacity of the body divided by specific heat. This MW is known as of your water equivalent. So numerically, I can say that water equivalent is equals to in CGS unit. In CGS units, specific heat of water is 1. So I can say that numerically water equivalent is equals to M into S. That means heat capacity. Formula is one and the same in your CGS unit. If it is in SI unit, divided by the specific heat of that elements. Okay. So now tell me what will be the units, beta, anyone? Water equivalent unit is in CGS system, I'll be taking it as of your grams, and SI system, I'll be taking that one as of your kgs. Okay. So water equivalent will be equal to M into S. So this is the numerical formula. I'll represent MS as of your mass of that one as of your W. So water equivalent will be equal to, what is the formula for water equivalent? MS, mass of the substance into specific heat of the body. Okay. So small point. During change of temperature. Whenever you give certain amount of energy, if you see that there is change of temperature, then we say that heat lost or heat lost or your heat gained is Q is equals to M into S into delta T. Delta T is your temperature difference. Okay, so whenever there is a difference in the temperature when you're giving heat, so heat lost or gain can be calculated by the formula Q is equals to Ms into your delta T. Okay, in tomorrow's session of the class, we'll try to complete your calorimeter, change of your state and journey of your ice participation, how to do the calculation mistakes of your what do you call that one, changing the state phase, that all we'll try to do in the tomorrow session of the class. Okay, sure. Thank you, beta. Bye.
Sir, notes.
I'll send beta. Yesterday I have sent it, na?
No, we didn't receive it.
You are in which group, beta?
Ali sirs.
Sure, I'll send today to the Ali sir. You just ask him, sir, once. I will send him today. Yesterday I have sent it to sir. Okay. Otherwise, you join my group, but you send me just a letter hi. I'll add you in my group because Ali sir need to take the screenshot of each and every notes and then send. Because
Okay,
there
sir.
is in that one, so you better join my group. You just take my. I have given my number yesterday. No, some of the students have been because I have added them. So just send me a hi with your phone number. I'll try to add it in that one directly.
Okay, sir.
Okay, sure. Thank you. Bye.
Thank you.